So these problems are going to be a decent review both of the new algebra and the old significant figures rules. If I'm working with a freezer that's 80 degrees Celsius below zero, which is pretty darn cold, getting on towards what we would refer to as cryo temperatures. If I want to convert to Fahrenheit or Kelvin, that's going to be two different equations that I break out. Remembering that with Fahrenheit, the Fahrenheit temperature we said was 9/5 times the Celsius temperature plus 32. So let's go ahead and put in what we know, negative 80. And we'll take this one step at a time. First thing we're doing is multiplying by 9/5. We're going to treat, by the way, the 9/5 and the 32 as exact numbers. If I do that, I get now negative 144. Note, I'm going to keep 3 significant digits because I'm doing multiplication and division, and this has 3. And then we're adding exactly 32 to that. And once that's all taken care of, I now have negative 112 degrees Fahrenheit. And notice, because this has uncertainty in the ones place, this will have uncertainty in the ones place as I add an exact number to it. So there's my Fahrenheit temperature, which feels even more frigid than it did as negative 80. Kelvins, on the other hand, is going to be a little bit faster. To do kelvins, I take the negative 80.0, the Celsius temperature, and I add 273.15 to it, and that should get me what I want, and that is going to be 193.2 kelvins. Notice I'm going to keep the tenths place this time because I'm just doing addition, and I have this one out to the tenths place, and again, this one, this, and this, all exact numbers. So we'll go ahead and keep this out to the tenths, round up to the 2. That's what I've got, 193.2 kelvins. So notice, of course, not negative, because it can't be, and certainly feels more toasty, but is actually quite cold. Now, a few years ago, when the picture on my Meet Your Professor page was taken, my wife and I had gone up to Milwaukee for winter break. And while there, in January, we experienced a negative 6 degrees Fahrenheit wind chill, which I just have to tell you goes right into your bones. We're going to try and make me feel warmer, just as we did a moment ago with the freezer, by converting that to kelvins. But what we have to remember is that in order to do that, I don't have an equation that goes directly from Fahrenheit to kelvins, so I can continue to use the same sort of logic that I've done with dominoes in the past. If I think about the first equation right here, this is a Fahrenheit to Celsius domino. This one over here is a degrees Celsius to Kelvin domino. And if I line those up one after another, I can make this trip. The only difference is I'm not going to set up a pair of conversion factors, I'm going to set up a pair of equations. And so here's what that'll look like. We start off again with Fahrenheit equals 9/5 Celsius plus 32. In this case, the temperature I know is the Fahrenheit one. It's negative 6. And unlike the first one where I just did some evaluation, this time I actually have to solve for my Celsius temperature. So first thing will be, anytime you're solving an algebraic equation, you untie it like a knot. You take the last thing that was done to this C and you undo it first. So first thing I'm going to do is subtract off the 32. That's going to give me negative 38 equals 9/5 C. Now I can multiply by the 5 and divide by the 9 in order to undo that. And that's going to leave me with negative 21 as my Celsius temperature. So negative 21 degrees C. Notice here that in this subtraction, I had uncertainty. Sorry, not in that one. In this one, because it's only a 6. That means I'm going to have uncertainty in the ones place after the subtraction too. And then when I do this bit, I'm going to keep 2 significant figures. So I leave it as negative 21 after the multiplication and division. This now, I'm going to take out and do the same thing I did up here. Negative 21 degrees Celsius plus the 273.15. In this case, the 15 is kind of for show, and my result here is going to be 252 kelvins. Again, I'm uncertain of that 1, which means I'm uncertain of the ones place as well in my result. Yeah, 252 Kelvin sounds way better than negative 6 Fahrenheit. Armed with an ability to go back and forth between these scales, we're ready to start doing some quantitative problems with gases.